I'm going to do 2 of these to get you started. And I think I'm going to start with the square root one because that would generally be a tougher one. So we'll just start with that one together. Oh, and I kind of said it, but hey guys, what's the parent function? Very good. You are so smart. Okay. So think about what that basic shape is. Already, like, what's the shape for a square root? Yeah, like everyone just kind of acts it out. Like it starts at the origin and then it's a half parabola, right? Like sideways. Okay. What are some of the transformations? Again, you don't have to write them unless you want to, but what's been done to this graph? Perfect. Up to what else? Reflect over y. Horizontal. Good, because it's backwards. Stretched by 2. So you're going to expect it to be going the opposite direction and be stretched out this way. Is this making sense? Okay. So instead of starting at the origin, we're going to go up 2. So you can put a point at 0, 2. That tells you where to start. And then I usually like at least 3 points. Not usually, I mean, that's the rule. You gotta show 3 points. So let's plug in something else. If you pick something that doesn't work out nice, it is not a big deal. You would just pick something else. You just have to, struggle through it and not be a giver-upper. What do you want to try and plug in? I'm going to shut that down right now. If you're not saying something helpful, just keep your mouth shut. Because I'm trying to teach the lesson to everyone, and I can't confuse the rest of the class. 2. Negative a half times 2. Negative a half times 2 would be negative 1. Square root of negative 1. It's imaginary, so that didn't work. Let's try something else. Let's do negative 2. Negative a half. Do you see how we tried it and it didn't work, so we tried something else? It's what you're going to need to do, okay? Negative a half times negative 2 is 1. Square root of 1 is 1 plus 2 is 3. So you get the point, negative 2, 3. Now I would like one more point, so let's try something else. And again, if it doesn't work, we'll just keep trying until we get something that does work. Bless you. Let's try negative 4. Negative a half times negative 4. 2, square root of 2. It's actually 1.41. I only know that because I teach calculus. Okay, but we don't want to plot that. Get your head up off the desk. Let's try something else. We just did negative 4. Negative a half times negative 8. 4, good. Square root of 4 is 2 plus 2 is 4. So negative 8, 4. So does it look like a square root graph? Does it look like the half parabola? Does it look like it's going backwards because of the negative? And does it look like it got stretched this way? Okay, so you can use that to like make sure it seems right. And then I'm going to do the exponential one for you because I know that that's always tough too. Which one back here is exponential? 9. Let's do number 9. Okay. I already told you it's exponential. It's going to be like a swoop. What are the transformations that have been done to it? There's 2 things. Down 3, perfect. Reflect over y. So instead of swooping up, it's going to swoop down. Okay. So start by going down 3. That's where the horizontal asymptote is going to be. And then we will plug in some numbers until we have 3 points. So what would you like to try? Let's do 1. If you plug in 1, it will become negative. So negative 1. 2 to the power negative 1. Let's pick something else. Do negative 1. If you plug in negative 1, what's going to happen? Be perfect. 2 to the 1, 2 to the first is 2. Very good. Minus 3, negative 1. So negative 1, negative 1. What's the other really easy number to plug in? You want to start with 1s and 0s. Let's try 0. You can't negative a 0. 2 to the 0 power. Good. You guys were confident about that too. I like that. 1 minus 3. Good. So 0, negative 2. And then I would just like one more point. What do you want to try and plug in? do -2. If you plug in a -2, the negatives cancel, it'll be +2. 2 to the second, 2 squared. Perfect. 4 minus 3 is 1. So -2, 1. And oh my gosh, it is sloping downwards. That's because of the reflection. So let's flip back to the front. What is this parent function? So what shape should it be? You're like halfway there, okay? It shifted what direction? Left 1. So we're going to go left 1 and put a point. That's the center of the V shape, okay? Now you can make a table, but here's what's kind of nice about the absolute value ones. Each side of it is linear. So you can just use that -2 as your slope, and it's kind of like a shortcut. If you made a table, 100% valid. But if you want to kind of use that to like make it a little easier on yourself, you can use that -2 as a slope. See how it's down 2 over 1? I don't know. Yes, are you following me there? Like your slope instinct kind of kicks in. Cool. What is this parent function? Good, and you're using the good vocabulary. It's going to look like steps. How did it shift? Left 1, good. Down 3. So you're going to go left 1, down 3, put a point. That is where your first step is. Now, what's the other transformation that happened? So the steps are going to be 2 units apart from each other. It got vertically stretched by 2. So they are 2 units apart. I'm hearing muttering about that one. It doesn't sound like angry muttering though. Are we okay? It went well walking around. It seems like it went okay. All right. What is this parent function? Perfect. It's a U shape. What do we call the U shape? Parabola. Perfect. It moved right 2 and then up 1. Go right 2, up 1. That's the center. We have a special name for the center for a parabola. Does anyone remember what that's called? What did you say? I don't know what that means, so I'm gonna have to Google that later. It might be a synonym. I'm not really sure. I'm gonna have to look that up. But no, it begins with a V. The center, vertex. Okay, so that's the center. Now look, if it's centered at 2, do you see how this is at 2? You want to pick numbers close to 2. Like you can plug in whatever you want, but stick close to 2. So let's try 3. Like you want to pick things that are going to be helpful for you. All right, y'all buckled in? Here we go. This is what you got to be able to do without a calculator. 3 minus 2. Good job. Times 2. 2 squared. 4 plus 1, 5. So you can plot the point 3, 5. And you can plot more points if you want, but if you know what the shape should look like and that it's going to be symmetric, you can take that point and just reflect it over here, and there's your graph. It's like work smarter, not harder kind of thing. All right, we did number 4. Number 5, what is that parent function? Cubic, so it's going to be like the wiggly thing. Thank you. What direction did it shift? Right 2, good. So go right 2 and put a point. And I'm going to make a table of values. Now it is centered again at 2. You'll notice I use 2, 3, and 4 a lot because you don't have a calculator and I have to keep the numbers small for you. Without a calculator, I have to keep everything manageable, which is actually really nice. Okay, so we want to pick a number near 2. What do you want to try? Let's try 3. You ready? 3 minus 2 cubed. 1 times -1/4 would be -1/4. I do not want to plot a -1/4, so let's try something else. 3 wasn't good. Let's try 4. 4 minus 2. 2 cubed. Rewind. 4 minus 2. 2 cubed. 8. Good. A fourth of 8 is 2, but it will be -2. There we go. 4, -2. Now, again, you can plug in more values. You can plug in values all day if you want, but if you know that it should be a wiggle, like I know this is the center. So if this goes down here, I know the other point's got to be up here. And so you can just do the symmetric point. Like I know it's going to be, what is that, 0, 2? Like just do the symmetry and then it saves you some work. Again, it's work smarter, not harder. I'm not telling you to be lazy. I'm just telling you to be efficient. If there's a shorter way to do something, always do that, right? While still also getting the correct answer. You like that one? Whenever I do these ones, I don't know. And once you see it, you almost can't unsee it. It looks like a reindeer to me. These are his eyes, these are his nose, and these are his antlers. It's kind of creepy. All right, what is this parent function? Cube root. It's going to look like this one, except sideways. How did it get shifted? Left 6, good. Down 2. All right, go left 6, down 2. So I'm going to make a table. We are centered at -6. Do you see this here? I'm just pointing to it. We're centered at -6. So you want to pick numbers that are close to -6. What do you want to try? Let's do -5. -5 plus 6. 1. Cube root of 1? 1. Good. Don't overthink it. 1 times 3 is 3 minus 2 is 1. So -5, 1. Oh, whoops. And again, if you know the symmetry, you don't have to do any more work. This is the center. I know it's going to be this sideways wiggly thing. So I can just take that point, reflect it down here. And it's going to do something like that. It got stretched vertically to 3 times its size. If you're like, wow, that looks really tall, that's the reason why. It's 3 times as tall as it was before. I'm going to break this thing. Correct. Yeah, and almost like a slope. I hesitate to use that word because it's not technically, but you know what I mean. Yes, exactly. That's how I think it in my brain too. I hear that all the time. So I'm going to say that for everybody because I get this all day long in pre-calc classes. Well, it makes sense when you do it. I've been doing this a long time, first of all, but that's why I try to say the same things over and over again. I try to be very repetitious so that if I say it over and over again, like there will be a recording of me in your brain saying the same thing over and over again, and then you'll be able to just kind of like hit play on that and know what's going on. All right, what is this parent function? Rational. I do not require specific points plotted for rational because those graphs are really weird. All you have to do is get the asymptotes in the right spot. So how did it shift? Right, 5. Okay, so we're going to go up 3. You know what? I'll use a different color for this. Up 3 and dot in the asymptote. Right 5 and dot in the asymptote. No points. You're not going to plot any specific points. If it feels like we moved the whole axes, we did. Do you know how people can like, I mean, I can't do this, but like pull a tablecloth out from under everything on a table? It's like that. We like shifted, we like pulled the axes like out from under the thing. Does that make sense? Like we just moved the whole thing. And then you're going to just draw in the graph. So those graphs look really complicated, but they're actually not all that hard because, I mean, I'm not going to make you plot anything real. I'm not picky about those ones, I guess I should say, because they're so weird. Number 8 is the easiest one on here because what shape is that? It's linear. It's a line. It is good old y equals mx plus b. So where are we going to start by putting a point? 0, -2. It's going to go down 2. And then your slope is 1/4, up 1/4. Oh, and for the rational graph, I wore my rational graph shirt today because I knew we were graphing. It's reflective. All right, so up 1/4 or down 1, or I shouldn't say over, up 1 right 4 or down 1 left 4. Here's our line. All right, we did the exponential one. Exponential and logarithmic are inverses of each other. So if this is a swoop, this one's going to be a sideways swoop. This one's really hard. And for right now, I'm only going to require you to plot 1 point. Later on this year, we're going to do a whole unit on like the exponential and logarithmic graphs. Right now, we're only going to be able to do 1 point without a calculator. How did it shift? Left 4. So you're going to go left 4 and dot that in. The exponential has the horizontal asymptote. The logarithmic has the vertical asymptote. We're only going to get for right now 1 point. I'm going to teach you later on this year when we cover it in more depth how to get more points. But for right now, we're just going to do 1. Here's the only one I want you to know. Any log of 1 is 0. When I say any log, do you see how this one's log base 2? Do you remember vaguely from, I know you don't do too much with logarithms in algebra 2, but do you remember how it could be log base 3, log base 5, log base 7? Any log, it doesn't matter. Do you remember what it is if it's not written? It's log. Oh, you guys are awesome. Okay. It was what? Oh, you guys did do a lot with it. Oh, okay, cool. Then you're ready. Any log of 1, it doesn't matter which kind it is going to give you 0. So that doesn't mean we're going to plug in 1. What would we plug in for x so that we can log 1? Like what would x have to be? -3, good. So -3 plus 4 is 1, and then any log of 1 is 0. So that's the only point you're going to be able to get without a calculator for right now. Again, I'm going to teach it to you in more depth later this year when we get to that unit. Now here's the only thing. Does it swoop up or does it swoop down? Why down? Because there's a negative, so it has to be decreasing. It's going to look like that. That was really hard. That was a very tough problem. As long as you don't cross the asymptote, you're good. And then these last two are the trig ones. They're sine and cosine are essentially the same graph, just like moved over a little bit. Do you remember what they look like? Everyone just always goes like this. What's that? Yes, which one starts at the origin? Sine. Okay, so it would start at the origin, but it moved up 2. So we're going to start at 0, 2, and then you can go ahead and wave from there. And you can go in the other direction too if you want to. Like it's going to go forever. Let's have this conversation really quick. Don't put arrows on the ends of those. Here's why. What does an arrow mean? It's going to go forever that direction. And is this graph going to do that? It's going to continue waving forever. So just don't put anything on the end because an arrow is not accurate. It's not going to continue going that direction forever. All right, and then cosine. Where did cosine start? At 0, 1. Now this one got reflected. Just watch me point to this. It got reflected over x. So instead of starting here, it's going to be down here now. And then it also did what? Went down 1. Let me point to it again. It usually started here. We reflected it down to here. That's the negative. And then it moved down 1 more. And then you can wave from there. So it usually starts up here and like goes down from that, but it's reflected and we moved down another unit. That's going to do something like that.